Okay, good morning. Welcome to the Cosmology Discussion Group for 21st of December, 2025. My name is Harry Ricker, and this morning we got Vladimir who's going to talk to us. So I guess we can get started.
Sure.
Looks like it's doing it. There we go.
Let me maybe increase. Okay, maybe I will take care about this size of it. It will be easier for you to follow me. It's okay right now. Can you
Yeah.
read it?
Yeah.
Because as
Yes.
usually, I have so much information, I must read it as Nick advised me 2 years ago. That's why I'm very sorry. Ian, I started with you 2 years ago, eight presentations. And I
Right.
have my experience with you guys only because Nick, he introduced me, invited me, and he took care about my first 8 presentations. Okay, thank you so much for coming. The main idea of my presentation today, very simple. There is so-named Hubble tension. The Hubble tension is a very complicated, huge problem for standard Big Bang model. At the same time, this problem for Big Bang model is an advantage, is an evidence of my model. Simple like this. Make your drawback your advantage. This is a very good rule. The persistent discrepancy between measurements of the Hubble constant, the fundamental parameter describing the expansion rate of the universe, has become known as the Hubble tension. Observational determinations of this parameter derived from different methodologies and distance ladders disagree by amounts far exceeding their quoted uncertainties, suggesting that the standard cosmological framework may be incomplete, absolutely bad. In this article, we examine the large-scale mass structures of the world, superclusters and galaxies, and analyze their origin and evolution within the hypersphere world-universe model, a proposed transformative new cosmology. Unlike the Big Bang model, which assumes a practically infinite, homogeneous, and isotropic universe expanding from an initial singularity, WC envisions a three-dimensional, finite, boundless, observable world as a patchwork quilt composed of more than 1,000 luminous superclusters that form independently in different regions and at different cosmological epochs. While the cosmic medium of the world in WC remains homogeneous and isotropic, the spatial distribution of macro objects is inherently inhomogeneous, anisotropic, and temporally not simultaneous. We show that this intrinsic patchwork quilt structure naturally accounts for the observed variations of Hubble constant, offering a compelling explanation for the Hubble tension within the WC framework. Simple like this. Introduction. The workshop Tensions Between the Early and the Late Universe was held at the Cavell Institute for Theoretical Physics on July 15, 17, 2019 to assess the growing evidence for discrepancies in key cosmological measurements, most notably the value of the Hubble constant, and to examine recently proposed ideas aimed at resolving this tension. During the workshop, multiple new observational determinations of the Hubble constant were presented using a variety of independent probes, including Cepheid variables, strong lensing time delays, and others. Importantly, the emerging discrepancies do not appear to depend on any single method, data set, or research group. It's a very important, it's repeatable. For experimentalists, the most important parameter is repeatability of any experiment. It's exactly what's happened with Hubble constant. In their summary, by the way, astronomers has done so great job, so good results. I cannot believe that I can see these measurements with so good accuracy, high accuracy. I don't know how they're doing. I'm very impressed with astronomers right now. In their summary article, tensions between the early and the late universe were the Treo and Rias Nobel Prize laureate in physics, emphasized that while the standard cosmological model successfully accounts for observations spanning a wide range of epochs, from primordial nucleosynthesis to the present day accelerated expansion, it is not guaranteed to remain valid as the precision of cosmological parameters continues to improve. Increasingly precise observations from different cosmic eras may eventually strain the model's internal consistency. The growing mismatch between early and late universe determinations of cosmological parameters, particularly the Hubble constant, may signal the need to extend the standard model and could point toward new physics. It's very important. It's their prediction that maybe you could point toward new physics. It's exactly what is my point. The results of measurements of the Hubble constant obtained between 94 and 2025 show that the values of Hubble constant vary substantially depending on the methodology used. The disagreement between the measurements often far exceeding the quoted uncertainties clearly illustrates the severity of the problem. The average value of Hubble constant span a broad range from 66.6 to 76.9 kilometers per second per megaparsec, with 21 measurements lying between 66.6 and 68.76 kilometers per second per megaparsec, and 30 measures between 69, 32, 76.9 kilometers per second per megaparsec. Let me stress that the first 21 measurements have a very narrow range on the and it's because it's a cosmic microwave background data only. And 30 measurements between these and these numbers, it's only connected to the galaxies, different type of measurements with galaxies, with some stars or something like this. You see the difference? Cosmic medium and stars, galaxies. The persistent and statistically significant inconsistency is known as the Hubble tension. In 2019, Mann summarized the situation in the article. One number shows something is fundamentally wrong with our conception of the universe. He was absolutely right. And underscoring that the tension represents a major challenge to a standard cosmological model. You see, I referred to the papers and to the opinions in 2019. It is close to 7 years, 6.5 years already passed. Microstructures of the visible world. The Laniakea supercluster is a vast galaxies supercluster that contains the Milky Way and roughly 100,000 neighboring galaxies. You can see on this figure, this circle, not circle, close to circle, around this Laniakea supercluster. I will show, this is the center, so great attractor, and this is our Milky Way here, far away, 250 million light years. It is one of the largest known superclusters with an estimated binding mass of 10 to the power 17 solar mass. Nearby major superclusters include the Shapley, Hercules, Coma, and Perseus Pisces superclusters. The distance from Earth to the center of Laniakea supercluster is approximately 250 million light.
Uh-oh,
I can't hear either.
I think he
Take a look.
froze.
We have one.
Yeah.
Oh, there we go.
There you go. Okay.
No, my internet connection. I restarted it. I'm sorry. Let's continue. Maybe if it will continue, I will restart my computer, but hopefully not. A key structural feature of Laniakea is the great attractor, a massive region acting as a gravitational focal point for the galaxies within Laniakea superclusters. Although not a single object, it represents a dense concentration of galaxies and dark matter located behind the zone of avoidance, making direct optical observation difficult. Nevertheless, its gravitational influence is unmistakable. This is a very important point. There is a great attractor. You can hold in your mind solar system. You have your sun and you have your planets. Instead of sun, you have great attractor, and instead of our planets, about 20 or something like this, we have 100,000 galaxies. It will be easier for you to understand my model and my point. Key details. Laniakea supercluster, a vast supercluster of 100,000 galaxies, including the Milky Way. The name Laniakea means immense heaven in Hawaiian. You know why? Because it was revealed in Hawaii telescope. Truly, it's a great astronomer. He put this picture. You will see, I followed his idea, experimental idea. This picture of the world was drawn in 2014. He put all of this information and nobody took care. Everybody talking about initial singularity, but he showed this picture. I adapted this picture from his paper 2014. Let's continue. Great attractor, the dynamical center of Laniakea supercluster containing a mass of all 10 to the power 16 solar mass, shaping the motion and flow of galaxies within the supercluster. Our location, the Milky Way, sits near the outskirts of Laniakea within the Virga cluster, and it is moving toward the great attractor. Let me show one time. This is our outskirts of our Milky Way, and this is the position of great attractor. Influence of the great attractor is inferred from peculiar velocity of galaxies, systematic deviations from the pure Hubble flow. Although most galaxies are redshifted overall, consistent with cosmic expansion, the variations of these redshifts are large and coherent enough to reveal a net flow toward the attractor. These peculiar velocities range from roughly plus 700 kilometers per second to minus 7 kilometers per second, depending on the galaxy's angular position relative to the great attractor. The attractor itself is moving toward the Shapley supercluster. Also, the center of Laniakea has a redshift Z equal 0.708. This does not imply that it is receding from the Milky Way. Instead, the Milky Way is moving within the gravitational potential of the supercluster. Some galaxies in Laniakea supercluster are moving toward us, while others move away. Their redshift, therefore, depends on location, motion within Laniakea. The situation becomes even more complex for galaxies associated with neighboring superclusters. I will show you later. You see how we can rely on redshift blue shift, all this stuff. If the movement so random, so unpredictable, because we are moving inside of this supercluster, that's it. And the main our point is to be there, to see how we are moving inside of it. Figure 2, I will show you. You see the intersection of our supercluster and Perseus supercluster. You have one center, you have another one. And you have this is a galaxy's flow. And this intersection between them, you see, they are separate, but there is intersection of these filaments. Let's continue. As noted by Gupta, more than 8,300 blue-shifted galaxies beyond the local group were known by 2009. The Andromeda galaxy, the nearest major galaxy, is also blue-shifted. Explaining these observations consistently within standard cosmology remains challenging. It's not challenging, it's impossible. According to WC, the Hubble parameter should be determined exclusively from the cosmic microwave background radiation, which reflects the properties of the homogeneous and isotropic cosmic medium. The value calculated in 2013 in our work, 68.73 kilometers per second per megaparsec, is in excellent agreement with the latest 2021 determination based solely on cosmic microwave background data. Compare apple to apple. 68.7 plus minus 1.3 kilometer per second per megaparsec. It's happened, oh my goodness, 8 years later. This is prediction, and this is what they measured. The mass-to-light ratio in the Virgo supercluster is roughly 300 times the solar ratio, and similar values are found in other superclusters. Already in 1933, Zwicky measured the velocity dispersion in the Coma supercluster and derived a ratio of about 500, concluding that dark matter must exceed luminous matter by a large factor. Such high ratios remain fundamental evidence for significant amounts of dark matter in the universe. Emphasize that the 100,000 galaxies within Laniakea are orbiting the center of the supercluster. That's right. They are bound members of Laniakea supercluster and did not originate from a single initial singularity in the sense implied by the standard model. Neighboring superclusters show analogous structures. I told you about this. It's the same structure. Together, they indicate that the visible world is in fact a patchwork quilt of more than 1,000 major luminous superclusters. You see this picture made in 2014, before my job, before my publications, and nevertheless, nobody paid attention. It is already existed, patchwork quilt. Only I proved it, I confirmed it, I calculated it. According to Tully et al., galaxies congregate in clusters and along filaments and are missing from large regions referred to as voids. These structures are seen in maps derived from spectroscopic surveys that reveal networks of structure that are interconnected with no clear boundaries. You see, there is no clear boundaries, and he wrote, it is his words. He is a orthodox. He is following Big Bang model. That's why, in his view, you have your extrasolar system, then galaxies can combine into superclusters. It's a long way. How it could be, I don't know. Wang et al. Made a great discovery. Most cosmological structures in the universe spin. All those structures in the universe form on a wide variety of scales, from small dwarf galaxies to large superclusters. Possibility that filaments of galaxies, cylindrical tendrils of matter hundreds of millions of light years across, are themselves spinning. These filaments spinning We have found that these objects to display motion consistent with rotation, making them the largest objects known to have angular momentum. These results signify that angular momentum can be generated on unprecedented scales. You know how they found it experimentally? They watched redshift from two sides of this filament. If you have your rotation, one side is moving to you, you have your blue shifted, the other side is going out of you. And this difference shows that there is a rotation of these filaments. Simple like this, experimental results. I'm very impressed. You know, astronomers done great job. I have no problems with them. On the contrary, I'm very impressed. Lopez reported about the discovery of giant, almost symmetrical arc of galaxies, the giant arc, spanning 3.3 billion light years at a distance of more than 9.2 billion light years away that is difficult to explain in current models of the universe. This new discovery of the giant arc adds to an accumulating set of cautious challenges to the cosmological principle. The growing number of large-scale structures over the size limit of what is considered theoretically viable is becoming harder to ignore. Can the standard model of cosmology account for these huge structures in the universe as just rare flukes, or is there more to it than that? You see, we have arc with length 9.2 billion light years. We have our universe, 13.8 billion light years. Come on, what kind of homogeneity you can even suppose in such a universe, and to calculate and do your calculations with Big Bang model, taking into account this homogeneity. It's unbelievable. It's unbelievable. How they can do it, I don't know. What is the logic of them? WC, these latest observations of the world can be explained in frames of the developed WC only. Galaxies do not congregate in clusters and along filaments. On the contrary, cosmic web, that is networks of structure that are interconnected with no clear boundaries, is the result of the explosive volcanic rotational fission of universe created matter cores of neighboring superclusters. Generation of angular momentum across the scales provide UC matter cores of superclusters through the explosive volcanic rotational fission. It's very important, rotational fission. Spinning cylindrical tendrils of matter hundreds of millions of light years across are the result of spiral jets of galaxies generated by UC matter cores of superclusters with internal rotation. The giant arc is the result of the intersection of galaxies' jets generated by the neighboring UC matter cores of superclusters. 14.77 billion years ago, when the Laniakea supercluster emerged, the estimated number of UC matter major superclusters in the world was around 1,000. It is unlikely that all of them gave birth to luminous superclusters at the same cosmological time, being far away from each other. The three-dimensional finite boundless visible world presents a patchwork quilt of different major luminous superclusters which emerged at different cosmological epochs. The main conjecture of Big Bang model, projecting galaxy trajectories backwards in time, means that they converge to the initial singularity at t equals 0, that is an infinite energy density state, is wrong, because all galaxies are gravitationally bound with their superclasses, as I demonstrated you on figure 1 and figure 2. Absolutely wrong. And what is important? It is experimental results, guys. I'm experimentalist. I'm trying to explain experimental results. And this, I showed you experimental result obtained by Tully and his team. Explosive volcanic rotational fission model. Universe created matter. In our previous articles, we followed the standard paradigm of dark matter, which is not appropriate within the framework of WC. Instead, WC posits that the world consists solely of particles of ordinary matter, protons, electrons, photons, and neutrons, and a distinct class of particles created by the eternal universe itself. These particles, called universe-created particles, constitute a new type of universe-created matter. Let me at this time to tell the great thanks to my friend, Harry Ritter. 1.5 years, close to 2 years ago, he put my attention to this dark matter. He told me it's not dark matter at all. That's why only thanks to him, I introduced a new definition. Universe created particles, not dark matter. They're totally different, new type of matter, but it's not dark at all because dark was usually invisible. Harry, thank you so much. You've done a great job for me. In 2024, we introduced the term UC particles, which possess the following key characteristics. They can be fermions or bosons. Their rest energies are given in table 1. I will show below. Their rest energies are given in table 1. I will show later. They interact via the weak interaction. They undergo self-annihilation similar to Majorana fermions. Ordinary particles are produced as byproducts of UC particle self-annihilation. Ordinary particles, this framework allows an easy conceptual transition from traditional dark matter with letter D to universe-created matter, UC matter, as used in WC. Optical invisibility versus multi-wavelength observability. The universe-created particles are dark only in the narrow sense that they are optically invisible. When observed through telescope using visible light. However, modern astronomy spans wavelengths from radio to gamma rays, and in this broader context, UC matter is not dark at all. The diversity of non-optical observations support this view. Sinus X1 that was opened 1971, they revealed it 118 years later than the idea of them. The first known X-ray binary as a persistent bright source of hot X-rays up to 60 kiloelectron volts. You cannot see X-rays on the Earth because of atmosphere, but in the space you can see easily them. In 2000, Minchin et al. Discovered the binary galaxy system Virgo H121 NGC 4254 exhibiting strong 21 centimeter radio emission. It is invisible, the whole galaxy, but there is a 21 centimeter radio emission. Two origins of radiation in the world. WC distinguishes the radiation of ordinary matter from the universe-created matter. Ordinary matter radiates electromagnetic waves from radio to X-rays through electrons outside nuclei. For example, Livermore experiments probed nitrogen gas at X-rays energy up to 8 kiloelectron volts, artificial 8 kiloelectron volts, the highest ever achieved at an X-ray free electron laser. Universe-created matter radiates gamma rays emitted by nuclei as a result of UC particle self-annihilation. Their rest energies span 18 orders of magnitude. I will show you in table 1. producing a wide variety of gamma ray signatures. Properties of the multi-component UC meta system. This multi-component UC meta system was introduced to explain the diversity of very high energy gamma ray sources observed in the visible world. The diversity of UC meta cores of macro objects, superclusters, galaxies, and extrasolar systems, which in WC function as fermion compact objects and UC meta reactors. Because UC particles carry no electric charge, their masses cannot be directly measured through mass spectrometry. They can only be detected indirectly via their annihilation signatures. Observable signatures of UC particles self-annihilation. Expected rest energies from UC particles self-annihilation include 1.3 tera electron volt, 9.6 giga electron volt, 70 mega electron volt, 340 kilo electron volts, 3.7 kilo electron volts, and zero 0.2 electrovolts. These energies appear in the spectra of the diffuse gamma ray background. I found a lot of signatures for these particular numbers. Emissions from various macro objects throughout the world. I found these references too. There is a special paper about this revealing experiments. We associate these observed gamma ray features with the internal structure of macro objects, their nuclei and shell compositions. Different combinations of UC particles naturally yield a corresponding diversity of gamma ray lines. Thus, within WC, the observed richness of very high energy gamma ray sources receives a coherent and natural explanation. Always, you don't have gamma ray only one line. You have a broad band radiation, but you have some peaks exactly according to the numbers I showed you up. One, universe created particles. This is the rest energy for the equations for these rest energies. This is the values I named it. This is the fermions, four of them, and this is the bosons named Dirac, Elop, and Xion. In this table, the basic energy unit E0 equals to Hc over 8, 70 mega electron volts, where H is the Planck constant, C is the gravity dynamic constant, A is the basic length unit, and alpha is the dimensionless Rydberg constant. I talked many times about these values, and this is a well-known constant.
All right, we got 4 minutes.
Okay. Let's try to, I don't know, can we? Okay, if you have any questions, I'm ready to answer your questions right now, but
We're going to
5
take a
minutes.
pause. Take a
Okay.
pause then.
Okay. Okay. How to
Got
do
any
pause?
questions? I don't think we
Yes.
got any questions.
Okay, let's continue. Whenever we'll stop, I will continue later. Don't worry.
Well, it looks like this is getting what I find interesting is that you're basing your your particles theory, your speculation, I guess, if you will, or your predictions about particles based on gamma ray spectral lines. That's just to clarify that, right?
You're absolutely right. I saw, first of all, these measurements, gamma peaks. And then I found this correlation between gamma peaks and my, particles. Simple like this. I was thinking about this model in 2001. But my paper I published on 2013, 12 years thoughts, evaluation, estimations, looking around, and only then I put my numbers in my first paper. That's it, simple like this. I'm experimentalist, First of all, take a look what astronomers achieved and then put these numbers into your theory. It's exactly what I've done. But nobody believe it. Okay.
All right. The other, I take it that mainstream doesn't really have a very I don't think they have an explanation of where these gamma rays
No, it's
signals are coming from.
unbelievable. No, they have it. Some accelerators, some lasers in the world, something, unbelievable. I don't want even to mention it. It's so stupid, but they didn't have a choice. This is the point. If you don't have my pattern, how you can explain these gamma peaks? You see, there's they're trying to do something. They're very smart, but it doesn't have any logic. They're trying to only. There are no calculations of them. It's impossible. They measure, they say, oh, it might be this and this and this. Even Fermi bubbles, they have all the range of these gamma rays, with a huge range of the wavelengths. The energies. I don't like gamma wavelengths. Forget it. It's an energy. And they keep explaining it. There is a variation in gamma radiation of Fermi bubbles. You have huge bubbles, and different areas radiate different gamma rays. Different. Oh, come on. No, we'll continue or we'll stop at that
Well,
moment
there
because
are
it's a very good
traditional
questions you ask. But what is
their
important?
traditional explanation for these high energy sources is black holes, and I take
No
it that
black holes, I don't want even to name. We should forget about Big Bang model and about all these explanations because it doesn't work. It's obsolete. It was maybe good 100 years ago, 120 years ago, but it's not now. It's obsolete. We must stop, forget about it because it's always bullshit. And it's not because people they're stupid. No, they had a boundaries of Big Bang model. They wanted to put their explanation inside of this Big Bang model. Who is the main problem? Who is the main drawback of the contemporary cosmology? Big Bang model. We must stop using it. We must go to my model. Then you will easily explain of all your experimental results. I'm experimentalist by nature. Believe me. That's why I do believe, and I will, by the way, later I will refer to Feynman about this. I like Feynman with this, citation. We'll continue, and you will see I named him, and he was exactly right. If you have experiments and they're following your theory, it's good. If even one result it's not following, forget about it. It doesn't work, forget it. Throw it away.
all right, we're going to end here pretty quickly. Okay.
Do you have any other questions? Ian, maybe you have.
All right. That was okay. So I guess we can continue on here.
I think Vladimir was asking
Request.
me if I had any questions. I have maybe a sort of a comment. I actually made this to Vladimir because we're talking about his giving sort of a comprehensive talk, in the new year to one of the Saturday sessions as well about this. But the point I made is sorry, just a slight comment. I'm not sure if
I came back. Okay, I'm listening to you, Ian.
Okay, I'm not sure if we're looking at something from different angles, and maybe we're not very far apart from each other. I'll tell you what my ideas are in a second, or whether they're contradictory, because I start with the idea that actually this tension, a nice word which was invented by the astrophysicists to save their ideas about a linear relationship between redshift and distance. And of course, they've explained this by the expanding universe and therefore the relationship between velocity of recession and distance. But so since they're getting these different values all over the place, adopting different methods, the obvious thing to say, goodness me, these values of this so-called proportionality constant, Hubble's constant, we're getting such different values that there must be something wrong in our initial assumption that there's a proportionate relationship between Z and X. So instead of saying, oh, it's another paradox we'll have to explain, they say it's a tension. Oh, no, it's a nice word. No problem at all. But I maintain that the this so-called disparity of values comes from the incorrect assumption that the law is linear. Now, I think I've shown you in the past that I have an exponential type law, which is more consonant with assuming that there's a dissipation in the ether. So I suppose the point I put to Vladimir earlier is that it is possible that we're coming to a similar decision from different angles. I mean, he's saying, well, you have to look at the universe as a patchwork and the differences and all the irregularities and so on. And I've said, well, tension is just a way of saving an incorrect assumption, namely that there's a linear relationship between redshift and distance.
From one side, you can be absolutely right. What I mean, what is a linear law is not linear law. But what is important for me, for my model, it doesn't matter because never I use redshift, never in my model. Because if you have, suppose the solar system, you have your Earth and you have your Mars, Jupiter. Sometimes they're moving to us, sometimes they're moving out of us. I showed you this analogy with superclusters. You cannot, based on Z, on redshift or blue shift. There are so many blue shifted. That's why, in principle, you're right. But in my model, it's not a reliable parameter at all. A linear law, not linear law, who cares? Who cares? Because I don't use it at all. Because the main problem with this Big Bang model is not even how they measure redshift. The main problem is homogeneous, isotropic world with so huge macrostructures inside of it. You cannot go this way. It's absolutely, in principle, wrong. You can name only maybe redshift, huge one. I will show you up to 32 already now measured and so on and so on. You can see, you can tell that against your Milky Way, you have these galaxies so far away. But as an experimentalist, I believe to GWST. What I mean, we had Hubble telescope before. Now we increase sensitivity and resolution of our telescope 10 times at least. And you started to see some new galaxies far away. Hubble, he couldn't do it, but GWST can. That's it. I am experimentalist. For me, instrument is a very important issue. It's not linear redshift. The most important. You have your more sensitive, more resolution. You can see more further from this, Hubble, telescope. That's it. That's why
So
it
we're
might
both,
be.
yeah,
It might be, but for me, it does matter. It doesn't matter what kind of Z you have. Blue shifted, red shifted, tight light, not tight light, because it's not a critical parameter in my model. It's only some reference. You can refer, you can prove it, but who cares? For my model, it doesn't matter. And the main killer is initial singularity, homogeneous space, and so on and so on. In my model, there is no initial singularity. There is a great attractor in our Laniakea supercluster. And then this supercluster has all these 100,000 galaxies around this attractor. That's it. This is my small world, Laniakea supercluster. You can go to another supercluster. You will have your own world and totally new measurements of this redshift. Totally new. If you will follow the other comma, suppose, or some other, supercluster. That's why redshift, I don't discuss even. I don't discuss. I never touch it right now, especially. Sometimes, yeah, I touch at the very beginning. But right now, I can see no meaning for this parameter. If it's convenient for you, measure. If don't, I don't care.
Okay, let's
well,
continue
Sorry for
on.
my neglecting of your idea, but it's not because of you, because it's my idea about red shift, blue shift. That's it, simple like this.
All right, let's
Sorry.
continue on, and we can discuss these fine issues, these distinctions later.
Yes, we will do.
Try to
Macro
move through
object
here.
shell model. This is a very important point. In WC, the macrostructures of the world, superclusters, galaxies, and extrasolar system contain nuclei composed of UC fermions surrounded by nested shells made of UC matter and baryonic matter. These shells are arranged concentrically, like a Russian doll. Their structure follows a simple principle. The lighter the particle, the larger the radius, and the greater the mass of its shell. The heaviest particles occupy the innermost shells, the lightest form the outmost layers. A proposed weak interaction among UC particles maintains the structural integrity of all shells. Table 2 summarizes the parameters of macro objects, cos, modeled as the three-dimensional viscous fluid spheres whose high effective viscosity allows them to behave as solid-state objects. What do I mean viscous fluid spheres? This solid state we have in front of us, glasses. There is no structure. There is no some structure inside of glass as like crystal. That's why I put fluid spheres means glass. They're like glass. That's it. Simple like that. There is no miracles behind this definition. Table 2, parameters of macro objects, cos, composed of different fermions at present epoch. Very important. You see fermion with 1.3 tera-electron volts. We have the maximum mass about solar mass as put here. You see F2, the same story all around mass of the sun. When you put electron-positron shell around this nuclei, you have 3.3 million solar mass. 3.3 million solar mass. It's exactly our Milky Way galaxy center. UC4 with 0.2 electron volts and fermion rest energy. We have, UCF3, first of all. You have 60 billion mass of solar mass, 60 billion solar mass. And when we put UCF4, you have 2.1, 10 to the power 19 solar mass. I don't know how to name even number, but it's very important, huge mass. What is important? Let's continue. All these numbers, all the calculations I've done theoretically. I built the theory of fermion compact objects. In the very first my paper, I put my theory and I calculated these numbers not from the brain, from my head, based on the equation, on theory I developed personally. There was some estimation, but nobody developed this theory. I've done it. Long time ago. Shell composition and macro object types. Remember, I told you the divergence of particles should have different consequences. Based on the calculated parameters, WC predicts the following internal structures of macro objects. Cores of stars in extrasolar system consist of UCF fermion 1, UCF fermion 2 nuclei. Galactic cores contain these nuclei with shells of UCF3 and electron-positron plasma. I told you already. Cores of superclusters contain these nuclei surrounded by successive shells of UCF3 and UCF4. You see, very simple structure. You have your nuclei and some shells around. Accordingly, galactic cores are interpreted in WC as a supermassive compact objects. I named them compact objects, not black holes, composed of UCF1 and UCF2, surrounded by an outer UCF3 shell. Their maximum mass derived from the parameters listed in table 2 is approximately, I showed you already this number, 60 billion solar mass. Remarkably, this theoretical upper limit is consistent with observational data for the most massive known dark compact object, the central mass of the quasar ton 618. Take a look. They measured this experimental number. They done this number as a black hole, as a black hole. A major recent observational milestone highlighted the biggest. Okay, that's why I want to stress. They calculated experimentally this number, and they told that it's a black hole. I calculated this number in 2013, long time before, and take a look. With accuracy 10%, my calculated number corresponds to the maximum black hole mass achieved by these authors. A major recent observational milestone highlighted as the biggest breakthrough in physics 2025 is the work title, A Direct Black Hole Mass Measurement in a Little Red Dots at the Epoch of Reionization by Choose.Bali. Sorry, I cannot pronounce this name. It's more complicated than my Netchitailo name. In the abstract of the article, the authors wrote, we report the direct dynamical black hole mass measurement in a strongly lensed little red dot at redshift 70.04. The combination of lensing with deep spectroscopic data reveals a rotation curve that is inconsistent with a nuclear star cluster, yet can be well explained by Keplerian rotation around a point mass of 50 million solar masses, consistent with viral black hole mass estimates from the Balmer lines. The Keplerian rotation leaves little room for any stellar component in a host galaxy, as we conservatively infer mass of black hole only mass of the structure more than 2. Such a naked black hole, together with its pristine environment, indicates that this little red dot is a massive black hole seed caught in its earliest accretion phase. You saw from experimental point of view, it's brilliant results, brilliant. They've done everything to confirm that there is some dark, from their point, dark object with lensing, with spectroscopic, with everything as a naked black hole. From my point of view, it's simple. You have your nuclei already, but you didn't achieve your rotational, dismiss your, oh, okay, it doesn't matter. You didn't start generate the galaxies around. That's why it's a pristine. You see, I told you, all these structures may be done in a different time. They found the structure, this core, without any galaxies around. It didn't get already dismissed. It's all these galaxies generated around. There is no fight bond, not yet. There is no instability of this, core. I was so impressed when I saw this paper. I read it. I put even their own abstract, their own words. They put everything. 50 million solar masses. You have black, hole at 70.04 redshift means billions of years before, and you have already black hole without anything. And it's contradict even the main idea of black holes, a concentration of luminous galaxies, luminous, everything around to achieve even black hole. And you have your clean, naked black hole for free without any process before. It's so good advantage of this experiment. And what is important, it's absolutely right in frames of my model. Sorry for my emotions because I was so impressed. And I found this paper a few days ago. I was lucky. I was happy about these experimental results. Within the framework of WC, this object is not a black hole. Instead, it is naturally interpreted as a rotating supermassive compact object composed of UCF1 and OUCF2 nuclei and surrounded by an outer UCF3 shell observed prior detonation during its accretion phase. You see, it's developing, but not yet. There is no detonation. It is essential to emphasize that WC contains no black holes. Observational phenomena commonly attributed to black holes are instead interpreted as the manifestations of UC matter-based supermassive compact objects governed by the physical principles of WC. Empirical confirmation of WC predictions. The prediction 2013. The 2020 Nobel Prize in Physics awarded to Gensel and Guess for the discovery of a supermassive compact object. Take a look. Supermassive compact object at the center of the Milky Way provides strong observational support for a key prediction of WC first stated in 2013. They did name this object inside at the center of our galaxy as black hole. No, they made, and even the name of this, the Nobel Prize, if, supermassive compact object. They're honest astronomers. They found what they found. They name it what they can see. They cannot see. That's it. They were true scientists. True scientists. Everybody wants to tell right now, oh, they all revealed already black hole. No, it's not. They, in their words, supermassive compact object. It's exactly my point. Don't prescribe to people more than they told you. And what my proposal was, 2013, macro objects of the world have caused, made, it's my words, made up of the discussed dark matter, now you see matter, particles. Other particles, including dark matter and baryonic matter, form shells surrounding the cause. Simple like this. 7 years later, in prediction, result. This structure, now supported by precise stellar orbit measurements, remains a fundamental and distinctive component of the WC framework. It's very important. You know, people, they cried about the black hole, but unfortunately, it was not black hole. It was, this was, proof of my model. Angular momentum. Oh, it's a very important problem. The angular momentum problem is one of the most critical unresolved issues in the standard cosmological model. A viable theory of cosmic evolution must explain the origin and conservation of angular momentum across all scales. To the best of our knowledge, WC is the only existing cosmological model fully consistent with the law of conservation of angular momentum. To satisfy this requirement, a cosmological model must answer the following fundamental questions. How did galaxies and extrasolar systems acquire their substantial orbital and rotational angular momentum? How did the Milky Way galaxy give birth to numerous extrasolar systems at different cosmological times? If, if the Milky Way is approximately as old as the world itself, what is the origin of its enormous orbital and rotational angular momentum? A discussion of the beginning of the Milky Ways is required. Why is the oldest known star in the Milky Way, Methuselah, nearly as old as the universe? The solar system formed 4.57 billion years ago. What is the origin of its rotational and orbital angular momentum? This requires addressing the beginning of the solar system. You see how many questions in frames of an angular momentum. Please explain it. There is no explanation. As I told you many times, it's a pollution for Big Bang model. Rotational fission of the source of angular momentum. In our view, there is only one physical mechanism capable of imparting angular momentum to macro objects, rotational fission of overspinning prime objects, whose equatorial surface velocity exceed their escape velocities. According to the fission model, A prime object transfers part of its rotational angular momentum to the orbital and rotational angular momentum of the objects formed from it. Consequently, the rotational angular momentum of the prime object must exceed the total orbital angular momentum of its satellites. It's logic. Prime objects in WC and the dark epoch. Within WC, prime objects are UC matter cores of superclusters, which must accumulate enormous angular momentum before the birth of the luminous world. This requires a sufficiently long preparatory phase. We designate this interval as a dark epoch. You need time for it. And it forms the basis of a new cosmology in WC. Invisible epoch, I put this word invisible by telescope, lasting from the beginning of the world 14.22 billion years ago for 0.45 billion years when only you see matter macro objects existed. You have additional half billion years to do your job before you will generate your luminous epoch, luminous galaxies, and all this stuff. You have plenty time to accumulate mass and rotational moment, angular momentum at this half a billion years. It's very important. Luminous epoch beginning 13.77 billion years ago for the Laniakea supercluster. We know only for our supercluster. And continuing to the present, during which luminous macro objects emerged through the explosive volcanic rotational fission of supercluster UC matter cores and through UC particle self-annihilation. You see, we need, first of all, rotational fission to generate these cores, and then to start your job with self-annihilation of these UC particles, self-annihilation to produce matters, our ordinary matter. Then you can see it. Transfer of angular momentum in WC. The UC matter cores of supercluster are the primary engines of the visible world. During the dark epoch, they accumulated vast rotation angular momentum, which was subsequently transferred to the UC matter cores of galaxies during their rotational fission. Observationally, the majority of galaxies are disk galaxies, strongly suggesting a rotationally driven formation mechanism consistent with rotational fission. You see, even produce disk galaxies, you must have rotational fission to spread your solar system, extrasolar systems in a plane. The UC matter core of the Milky Way was created 13.77 billion years ago as a direct result of rotational fission of the Virgas clusters UC matter core. There are some local clusters, Virga cluster. UC matter cores of extrasolar system, planets, and moons formed through repeated rotational fissions of galactic UC matter cores at different cosmological times. For example, 4.57 billion years ago for the solar system within the Milky Way. Top-down formation of structure in WC. In WC, macro objects form in hierarchical top-down sequence. Superclusters, galaxies, extrasolar systems, planets, moons. This structure arises naturally from cascading rotational fissions of increasingly smaller UC matter cores, propagating the transfer and conservation of angular momentum throughout the world. You see, there is mechanism and there is a sequence of these events, how we can produce all these macro objects in our visible world. Formation of macrostructures. Cores of all macro objects share a common set of fundamental properties. Core shell structure. The nuclei of all macro objects are composed of the universe-created fermions. These nuclei are surrounded by concentric shells containing universe-created matter and baryonic matter. continuous you see particles absorption and matter production. Universe created particles are continuously absorbed by the cause of all macro objects. Ordinary matter, comprising approximately 7.2% of a total matter, 4.8% in the cosmic medium, and 2.4% in macro objects, is produced as a byproduct of UC particle self-annihilation and is continuously re-emitted by macro objects cause. Consequently, macro object cores function as UC matter reactors fueled by UC particles. All chemical elements, compositions, and radiative outputs are generated in situ through UC particle self-annihilation within UC matter cores. It's a principal point. It's a very important point. Many times I told you, everybody knows, even orthodoxies, that we have only 2.4% in macro objects of matter. And to develop theory based on 2.4% of matter, it's a bullshit. You cannot do it. You must take into account all the picture, all the participants of the world. Only then you can some reliable model. It's exactly what I'm doing with my model. Time evolution of nuclei and shells. Both nuclei and shells grow with the absolute cosmological time tau, according to size proportional to root square of tau, mass to the 3.402 power, and rotational angular momentum proportional to tau squared. It's a very important theoretical values, theoretical equations. Growth continues until a critical stability threshold is reached, at which point the system undergoes detonation. What is this as a critical point? It's this, it's a speed of equator. When you exceeded some level, you can throw away like a volcano. All this stuff around. Detonation and satellite formation. Overspinning UC matter cores. At the critical point, overspinning UC matter cores undergo detonation. This process releases satellite cores together with their orbital and rotational angular momentum. Nature of detonation. The detonation does not destroy the parent core. Instead, it manifests as a gravitational hyperflare, ejecting satellites UC matter cores while preserving the integrity of the prime objects. It's like, volcanoes on our Mother Earth. We have volcanoes, they walk, but we have Mother Earth on our hand, on our legs. Origin of diversity. The size, mass, composition, and angular momentum of satellite UC matter cores depend on local density fluctuations at the edge of the prime UC matter core and the cohesion properties of its outer shell. This naturally explains the observed diversity of satellite macro objects. You see, you have your firework and you can generate all the sizes of your objects, and it's random. You don't know which one will be where. Look at any picture of the volcanoes on the Earth. It's exactly the same point. Volcanic ejection mechanism. Satellite UC matter cores are emitted through localized eruptive regions, volcanoes, on the surface of prime UC matter cores. These eruptions occur repeatedly, giving rise to hierarchical structure formation. WC refers to this detonation process of prime UC matter cores as a gravitational burst by analogy with a gamma ray burst. We have gravitational burst. It's not interaction of two black holes, small 1 to 3 gravitational waves. No, it's a gravitational burst like a volcano on some huge macro objects made of dark matter. Universe created matter now. Repeating gravitational bursts. In the WC framework, recurrent gravitational bursts arise naturally through the following cycle. During each gravitational burst, a prime UC matter cause loses a small fraction of its mass, but a large fraction of its rotational angular momentum. It's exactly what's going on with our solar system. We have all the mass in solar system concentrated in sun, but rotational angular momentum of Jupiter much bigger than, much higher than sun. This is exactly the demonstration of this claim. After the great gravitational burst, the core resumes absorbing UC particles. Mass is proportional to tau in power 3, 1.5, and rotational momentum proportional to tau squared until the next stability threshold is reached and another great gravitational burst occurs. You see, why repetition? You concentrated, you achieved a new detonation point, you detonate, you release, and these cycles all the time. It's exactly what's going on with each galaxy. How you can talk, by the way, about these galaxies of supercluster if they generated in different times, I don't know. I don't believe redshift, you can use it, but I don't care about it. This cyclic process explains why satellites UCM core rotate about their own axis and satellites orbit the UC matter course of their prime objects. We have all these companions of our big center. You have all of them rotating around you and rotating around your own axis. You see why? Because of this mechanism. Afterglow phenomena. General afterglow. The afterglow of gravitational burst is produced by post-detonation process within the nuclei and shells of UC matter cores. Extrasolar systems. In extrasolar systems, the stellar wind is the afterglow of stars UC matter cores detonation. The core continues to absorb UC particles, increasing its mass proportionally to tau in power 1.5, while excess rotational angular momentum is shed through wind particles. You see why we have solar wind? Because of this process. You must release your center from angular momentum, extra angular momentum. Solar system, the solar wind represents the afterglow of the solar UC matter core detonation 4.57 billion years ago, continuously forming the heliosphere solar bubble. Galaxies. In galaxies, galactic winds are the afterglow of repeated galactic UC matter core detonations. In the Milky Way, this process continuously sustains the two UC matter Fermi bubbles. Nobody gave the explanation how it's going with Fermi bubbles. They are invisible, by the way. They can radiate only gamma rays. That's it. That's why we missed this elephant, huge structure in our Milky Way. But nobody can explain why it's happening this way. High tension explanation within WC. Observations show that the majority of galaxies in the universe are
Okay,
these galaxies.
this is know that we're coming up here with just a few minutes left.
Yes.
Do you want to pause here, or do you want to? Wait, we got 4 minutes.
It depends. If you have questions to the part we passed already, then the next session we will continue all of it because 2/3 we passed. We have 1/3
I'm
of
not
my
sure. I'm
presentation.
not sure you're going to finish this presentation within the next 40 minutes. It's not. It's not going that fast.
No, but page-wise, I passed already 9 and I have 5 left. 5.
All
That's
right.
why,
Well, all right.
it depends on
Let's
your
sort of.
patience. I know it's too much information. I know it's very tough for you to listen to me even. I know it. And I'm so sorry that you only 4 of us now participants of this talk. I will never give talk to our meeting because there is no interest in my model at all. The previous time it was 10 people and right now only 4 people. It
Well,
means
I
a
think you're
lot for me.
suffering from the closeness to Christmas, actually, to be fair.
Oh, come
Yeah, it's
on, it's
part
not
of it.
suffering of interest. Don't blame
No,
Christmas
I'm
time.
saying that's the
It's
reason we
not,
only have
it
four
didn't come,
people.
not yet. Forget it. It's only, by the way, I sent to all of you guys my, split paper. I know that during this week, only 8 people, they saw my presentation. Only 8. And it's all, not only our group, all the world around. No interest at all. No interest at all. That's why, Ian, I hope maybe your audience, your Zoom meeting will be more successful because more people will watch my presentation. And if it will go continuously, it will be 1 hour. Don't worry, it will be not more than 1 hour.
Well,
But what is
I
important?
would comment here that there's too much detail here.
Yes,
And
yes.
you're just you're the big picture is missing in all the detail. There's just too much detail. The big picture just doesn't come through, given all the detail. And I do see where there's connections. Um, you know, the it's it's difficult to explain what's happening, the way you're going in with too much detail. There needs to be a big picture. The big picture is kind of missing because it's lost in the detail. It's my comment.
You forgot the main picture, big picture. I gave it at the beginning, but it's too much information. You're absolutely right. And Nick, he told me 2 years ago, exactly that's why. That's why he recommended me to read my papers, to read my words, because it's too much. I absolutely agree with you. It's my drawback because I'm trying to convince you with all my details, experimental details, by the way, experiments. It is not my ideas. It's experiments that they're confirming, they're proving my model. That's why it is very important. What is important? I put everything in my mind to this particular article. And you know why? Because it's a final for me. It's the end of the story of
All right.
my
All right.
25 years of my work on this model. That's why I put everything what I knew, what I know, and what is important. Next, maybe 20 minutes, I pay attention very shortly to what you know. And I found some new results about, oh my goodness, you will see. I will not name it right now. You will see yourself. That's why I will do maybe next session shorter, missing all these well known by you parameters and all this
Okay. Well, Vladimir's missing. I hope he's still.
We frightened him away, I think. My mentioning Christmas and your mentioning that it was too much information.
Here he is. Here he is. I think.
Well, I wanted to. I thought we're going for a very long time here, and I wanted to get. Robert hasn't said anything, but let's continue on and see how far we can go, and in the next 40 minutes.
I'll try to do shorter, guys, because I overloaded it, no doubts about it. Sorry, I knew it. That's why I read, I showed you. You can read instead of me, together with me. It's up to you how to do this simply. Please, no.
See, if it isn't too impertinent, just to make a suggestion for your consideration in the future, if you say made out 6 slides or 8 slides, just with bullet points, because we're all a bit lazy, and then gave the reference at the very end, they can read your paper because we all have it. That might
Nobody
be
doing
easier.
it.
Sorry?
Nobody doing it. Nobody doing
No,
it.
but if you gave the presentation first with these bullet points, just, 6 bullet points maximum on a slide, and just indicating without all the details, I think, well, certainly I'd be a bit more curious. I'd say, goodness me, what does he mean by that? I better look up the paper. It's just a suggestion for the future.
Okay.
All right, let's move on here and see if we can cover the rest of this ground. I think the um, feedback would be very important, and I think the feedback, we need to have time for some feedback.
Oh my goodness. Cancel. Come on.
My comment has always been there needs to be people who do astronomy need visual aids. These ideas need to have pictures associated with them, and I think AI might be helpful in that respect, since all you have to do is give it prompts. But then you have to be careful that AI just invents stuff. Okay, Hubble tension. What now we're back
Yes,
to
yes, yes.
the
We stopped here. Let me try to be shorter and I will put less emotions even. And then I will show you the most important results I found not long ago, a couple days ago. You know, I'm always trying to see the advantages of astronomy. And all the time I'm trying to explain the new results based on my model. Hubble tension explanation with an WC. Observations show that the majority of galaxies, we started already. We done it? Yes, we done it. Yes, it seems to be done, or I can repeat it. Okay, let's repeat it. The measured redshift of the center of the Kia supercluster 0.0708. This value doesn't imply that Lagrangian supercluster is moving away from the Milky Way. On the contrary, it indicates that the Milky Way is moving away from the center of the Lagrangian supercluster. With the Lagrangian supercluster, some galaxies move toward the Milky Way, while others recede from it. Thus, the observed redshift of any particular galaxy depends strongly on its location and kinematics relative to the Milky Way. Kinematics, rather than on a universal recession velocity. You see, no correlation, not at all. The situation becomes even more complex when galaxies belong to different superclusters, which involves form at different cosmological times. In such cases, redshift is influenced not only by relative motion, but also by the epoch of formation of the host supercluster. Let me show this result. You know, it's a very important result. These results got by cosmic microwave background radiation. This is the latest. I referred to this number, 68.7 kilometers per second per megaparsec, and it's achieved in 2021. Take a look how close all of them to the same level. Look how good it is, how consistent it is. Origin of the Hubble tension. Okay, let me read then. Within the WC framework, the Hubble tension arises naturally due to the following factors. All determinations of the Hubble constant are model dependent. The available statistics are insufficient to justify averaging disparate measurements into a single universal value. It's bullshit because there is no data. Hubble's law, as used in standard cosmology, is valid only within the Big Bang model, where all galaxies originate from a single initial singularity, an assumption explicitly rejected by WC. Observational samples include galaxies belonging to different superclusters which formed at different cosmological times. Since Hubble constant is inversely proportional to cosmological time, the value of H must in principle be different for each galaxy because they created in a different time, depending on its distance and corresponding cosmological time. Jan, I'm trying to explain you why redshift not so important. Averaging values of H across different methods and objects, as commonly done, has no physical justification in WC. The only physical meaning determination of H is one based on cosmic microwave background observations. Now it's a very important, section. Let me read it, and then we will try to shut down. The fundamental differences between Big Bang model and WC may be summarized as follows. Initial conditions, Big Bang model. postulates an initial space-time singularity characterized by infinite energy density and an extremely rapid early expansion inflation. Within this framework, the three-dimensional universe has no center of expansion. Nobody showed me where its initial singularity was. I don't know, maybe you know. WC proposes that a fluctuation within the eternal universe gave rise to a four-dimensional nucleus of the world, whose extrapolated initial radius equals to a fundamental length unit A. It's 10 to the minus 14 meters. Not a big deal. The nucleus expands along the fourth spatial dimension at the speed c, interpreted as a gravitodynamic constant. This expansion produces a uniform stretching of its hyperspherical boundary, the world in WC, thereby accounting for cosmic expansion without invoking dark energy. You see, simple like this. You don't need dark energy. You have your stretching. Structure of the world. Big Bang model assumes an almost infinite universe that is homogeneous and isotropic on a large scale, centered conceptually around the initial singularity. WC describes a finite, boundless world, the hypersphere of the four-dimensional nucleus, constituting an absolute space. The visible world, which is a three-dimensional Hubble bubble, is a patchwork quilt composed of major luminous superclasses, more than 1,000, that emerged in different regions of the world at different cosmological epochs. Medium of the world. Big Bang model commonly implies a vacuum-like state for the early universe, with matter and radiation emerging later. WC introduces a cosmic medium composed of protons, electrons, photons, neutrinos, and universe-created particles, previously referred to as dark matter particles. The medium is homogeneous and isotropic, whereas the distribution of macro objects is spatially inhomogeneous, anisotropic, and temporally not simultaneous. Build your theory on galaxies. The rejection of the luminiferous ether in 1905 marked a pivotal moment in classical physics. However, the cosmic medium of WC may be viewed as a modern, physically grounded revival of this concept, one that restores consistency to classical physics rather than undermining it. It's exactly what done the contemporary cosmology with their quantum physics approach. Conservation laws, Big Bang model, does not explicitly address the physical mechanism responsible for the creation of angular momentum, nor does it embed angular momentum conservation as a foundational principle. WC uniquely provides a physical mechanism for the creation of angular momentum and is fully consistent with the fundamental law of its conservation. Macro objects formation. Big Bang model assumes hierarchical formation proceeding bottom up from extrasolar systems to galaxies and subsequently to superclusters. By the way, don't forget, before galaxies, we must have a black holes, and then you can start galaxies. WC proposes a top-down formation scenario in which superclusters form first and subsequently fragment into galaxies and extrasolar systems. This process occurs via explosive volcanic rotational fission of overspinning supercluster cores composed of UC particles. These cores were created by the eternal universe during the dark invisible epoch, lasting approximately 0.45 billion years. Importantly, the formation of galaxies and extrasolar systems not a completed process of the distant past, but it is ongoing. Conclusions. WC offers a fundamentally different physical picture of the world compared to Big Bang model. It challenges long-standing assumptions and provides new perspectives on cosmology and classical physics. While Big Bang model is primarily mathematical in construction, WC is grounded in physical mechanisms. Both models may initially appear extraordinary. However, a critical distinction remains. Big Bang model fails to explain a growing body of observational evidence produced by modern astronomy, including results from the James Space Telescope, whereas WC claims natural consistency with these observations. Ultimately, the validity of any cosmological hypothesis rests on experimental verification. As Richard Feynman famously stated, it doesn't make any difference how beautiful your guess is. It doesn't make any difference how smart you are, who made the guess, Nobel Prize, not Nobel Prize, it doesn't matter, or what his name is. If it disagrees with experiment, it is wrong. That is all there is to it. That's it. If this disagrees with experiment, it is wrong. Simple like this. This is what I want to talk with you about latest discovery from GWT. I will show you only these tables, Right now, and in our 2024 GW discoveries at the hyperfield, okay, we discovered galaxies with redshifts Z more than 10. Table 3 and 4 present the latest GWST results adapted from the Wikipedia 225 list of the most distant. You have your reference. Table 3, most distant galaxies with spectroscopic redshift determinations. It's absolutely strong. Right now, they name the maximum Z equals to 14.44 with this accuracy 200. That years they each emerged 280 years, million light years after the Big Bang. And this one with 14.1797, it's emerged 290 millions after Big Bang. Notable candidates for most distant galaxy. This galaxy with redshift about 32 and years after the Big Bang about 100 million light years. Shorter and shorter time for all this process. The existence of such galaxies at these epochs, only a few hundred million years after the Big Bang, poses a profound challenge to standard cosmological timelines. According to Big Bang model-based models, there has been insufficient time for the formation, assembly, and dynamical replication, relaxation of massive rotational supported disk galaxies with mature stellar populations. They cannot do it. There is not enough time. 100 million light years. Don't even name it. The growing cosmological crisis, let me tell you, it was in 2019 crisis with Hubble tension. Right now, the growing cosmological crisis, new one. As summarized in Beyond Discovery, something is very wrong with the universe. We thought we had it figured out, a solid theory that explained everything. And then the James Webb Space Telescope turned on. Almost immediately, it started finding galaxies that break the timeline. Massive, mature galaxies showing up way too early, like finding a fully grown forest before anyone planted the seeds. That doesn't work, but the galaxies are there. Okay, so maybe the timeline is off. Except the universe is also expanding at two different speeds, depending on how you measure it. And there are structures out there too big to exist. The numbers do not add up. And the more scientists look, the more cracks appear. Something is very wrong, and it keeps getting weirder. I like this sentence. I like this art because it's exactly the demonstration of the situation with our contemporary cosmology. These observations reinforce the conclusion that the current cosmological paradigm is under severe stress. The early emergence of massive, well-organized galaxies, the Hubble tension, the discovery of extremely large-scale structures collectively suggest that a fundamentally different physical framework, such as the proposed by World Universe Cosmology, may be required to interpret the data. This is my conclusion. Okay, there are some explanations of the latest GW discoveries. I gave this presentation 1 year ago, maybe 1.5 years. I will miss it. You're overloaded. That's why I will go to some new results you don't know, not yet. Observational support for WC from supernova cosmology. Let me remind you, the main advantage of our astronomers and cosmology now, supernova cosmology. We're based on that. Let me show you a very unique result I found a few days ago. Strong empirical support for the world universe cosmology interpretation emerges from the recent series of papers entitled Strong Progenitor Age Bias in Supernova Cosmology. It's reference 18, you can see it later. These studies demonstrate that the luminosities of type 1a supernova depend significantly on the age of their progenitor systems, introducing a previously unrecognized and substantial systematic bias into supernova-based cosmology. We done with orthodoxies, we done some claims, and now there are some experimental results. They claim they killed this claim. Progenitor age bias in type 1a supernova. As summarized by Sun et al., it's a big paper with a lot of authors. Supernova cosmology assumes that the luminosity standardization of type 1a supernova is invariant with progenitor age. However, direct measurements of host galaxy ages reveal a highly significant 5.5 sigma correlation between standardized supernova magnitude and progenitor age. This bias is not corrected by the commonly used mass step method. After accounting for this effect, supernova data align with Bower and cosmic microwave background results from DESI. Combining supernova, Bower, and cosmic microwave background reveals a more than 9 sigma tension with the LCDM model, suggesting a time-varying dark energy equation of state in a currently non-accelerating universe. I put their words. They found, based on their results, that this new stress, new problem with 9.6 tension. Okay, continue your supernova cosmology. Implications for cosmic expansion. After correcting for progenitor, the age effects, the combined analysis of supernova 1a, Bower, and cosmic microwave background data reveals a greater than 9.6 tension with the standard LCD model. The revised data favor a cosmological scenario in which the expansion of the universe is not accelerating at the present epoch and may instead be decelerating, directly contradicting the LSTDM interpretation that relies on dark energy with a constant equation of state. Resolution with the world universe cosmology. Let me tell you some details about this paper. What they found is absolutely unbelievable. We have supernovas. And what is important? The brightness of supernova depends where this supernova. And it turned out that closer supernova It's weaker brightness, weaker, less bright. And you have your further supernova, it's more bright. How come? Brightness of supernova, it was the some measurement tool to find out where it is. But test results, on the contrary, bright supernova far away, weaker supernova close to us. Unbelievable. This is exactly the end of supernova cosmology. Let me ask you the question: who else can now explain this problem? Okay, doesn't matter.
My
Resolution,
understanding is that they're claiming that this disproves dark energy. Okay, let's go to the conclusion.
not a dark energy, not a dark energy.
Yes,
It's the whole
their
picture.
the advertisement on YouTube was that dark energy is refuted by this paper. Let's move on.
Okay, okay. Okay, do you want to within? Okay, doesn't matter. Do you want resolution within whole universe cosmology? Let me tell you, and then conclusion. Within the WC framework, these results are not indicative of crisis, but rather a natural consequence of applying an inappropriate constant Ash framework to a universe in which the expansion rate depends explicitly on cosmological time. WC predicts that measurements of the Hubble parameter derived from macro object-based observation, such as supernova, will vary due to the spatial and homogeneity, anisotropy, and temporal non-simultaneity of luminous structures. In contrast, measurements based on the cosmic microwave background, which probes the homogeneous and isotropic cosmic medium, yield a consistent and physically meaningful value of the expansion rate. When this Hubble parameter is inferred solely from cosmic microwave background observation, the so-called Hubble tension disappears, providing strong observational support for WC and reinforcing its physical interpretation of cosmic expansion. Mainstream cosmology, operating within the framework of the Big Bang model, determines the value of the Hubble constant using a diverse set of macro-object-based indicators. These indicators are drawn from structures whose spatial distribution in the world is intrinsically inhomogeneous, anisotropic, and temporal non-simultaneous, inevitably introducing systematic dispersion into the inferred values of Hubble constant. In contrast, world universe cosmology maintains that the Hubble constant should be determined exclusively from the cosmic microwave background radiation. The cosmic microwave background reflects the fundamental properties of the cosmic medium of the world, which is intrinsically homogeneous and isotropic. These properties are largely decoupled from the formation, evolution, and spatial clustering of macro objects whose influence manifests only as a secondary perturbation. Let me remind you, it's only 2.4% of matter. Of course, you have some perturbations of homogeneous cosmic medium. From the WC perspective, the persistent Hubble tension is therefore not an anomaly requiring ad hoc corrections, but a natural observational signature of the patchwork quilt structure of the visible world. It reflects the inappropriate mixing of local environment-dependent measurements with a global parameter that characterizes the world as a whole. Let me tell you.
Okay, that was a lot. All right.
Okay,
We've got
one sec. Let me
we've
finish
got
my acknowledgments. As usually, to academician Prokhor, Manenkov, Dirac, and Tesla, Korda, and what is most important, I am also thankful to Ray Ricker for valuable comments and suggestions that greatly enhance the clarity and scope of this model. Harry, I always have in mind your view of my model, and I'm trying to do my way to satisfy your proposals. Thank you
okay.
so much, guys, for this for this talk.
All right, we got,
this is a
looks like we
references.
got 14, about 15 minutes.
Okay, you know, I missed some parts. I reported them before, and it does matter. What is important? Let me tell you guys my understanding. I knew that this overloaded paper, I knew all your point right now, guys, overloaded, no doubts about it. That's why I sent my paper article in on Monday. I suppose that the people they will read this paper and they will collect some questions to me after I will finish this reading. Unfortunately, it didn't happen. There is no interest in my model at all. There are only interest right now of 5 people. That's it, simple like this. Guys, I'm very disappointed after 2 years of my performances, my reporting about my models, and no interest with dissidents. How I can penetrate to orthodoxies if I don't have a proof of dissidents of my society? Unbelievable. I'm disappointed. Sorry, it's my feelings, but it's exactly what is going on. In 1 week, it's not enough to read it. It's a long story. And to find all these questions for you to ask me. Simple like this. Unfortunately, it
All
didn't
right.
happen. Sorry.
Okay. Well, I don't think you should
Thank you
be
so much for your
pessimistic.
attention and for your patience. Thank you so much.
Okay. Um, okay. Well, we rushed through it here to the end to get the comments. I'm wondering if what comments there are. Robert, do you have any comments at all?
Maybe a few. I don't know. There's an awful lot of detail here. And I sort of share Vladimir's frustration. I get the same thing. I think all of us do. And it's because everyone has something different to say. And there's something to be said for trying to find something that people agree on. I guess we all disagree with relativity. And since black holes are based off of relativity, I don't know if any of us believe in black holes. I know Ed Dowdy, who I knew pretty well. He thought there was good evidence for something very massive, like at the center of the Milky Way, and but without having to postulate a black hole, in which case you need an alternative theory. So and I gather, I think Vladimir's probably right about evidence from the James Webb telescope, although it would be good to bring some mainstream people in here because I'm sure they're also aware of the observations. And that is that it doesn't seem to, at least some of it, fit in all that well with standard models, in which case you can always adjust the standard model, but you can also look at alternatives. So I think there is something to be said for looking for common ground in any event.
Can I comment? Thank you so much for your comment. Let me give you the comment back. Let me tell you that during 12 years, I sent my papers to the standard cosmologists, astronomers, and so on and so on. I have got already, I have got the number 105,000 people during these 12 years saw my papers, watched my papers, read my papers. You see, more than 100,000 of them. But unfortunately, nobody from well-known cosmologists answered me, replied to me. This is the main point. That's why there is an interest. For the last week, by the way, 591 people saw my papers. I don't know they read totally. They read only abstract, whatever. But they opened my papers. 591 people during 1 week. It's a great result. It's a great interest inside of the community, physical community. But unfortunately, there is a conservator, orthodoxies, heads of these cosmologists, astronomers, and they rule all the rules against or any dissident, any alternative model. That's why, from one side, my model has an interest. And from another side, from the big guys, well-known guys, they don't have any interest in the healing of their own Big Bang model. They're going to separate. They have no goals. They don't want, they miss some points. They want to do everything to save Big Bang model. And unfortunately, they're smart guys. and they're doing against themselves. They're inventing some comments, some ideas, how to explain this and that, and so on and so on. Instead of taking this model, it's only basis. To develop this basis, you must put all the efforts of the whole physical community. Nevertheless, it will never happen if the hands of them will start. Okay, let's start everything from the beginning. We have some basic model. Let's start developing it, and then it will be something. Unfortunately, it didn't happen for after 12 years of my publishing. Even in my journal, I published only 40 papers, 40 papers, and it's not well-known journal. That's it. Nobody wants to see.
All right.
That's why I tried to do something with you. I supposed to have a dissident support. Unfortunately, it didn't happen with you too. Unfortunately, not with you personally, but with our dissident community. 3,000 more people
Well,
and no interest at all.
okay. Well, the dissident community isn't very isn't is as diverse as it's not a consistent. I mean, we're not a consistent thinking group. So we're not, the fact that we're dissidents doesn't necessarily recommend us to be coming together to agree. The fact that we're dissidents means we disagree. So,
Let me
okay,
tell you
I
first.
do want to comment on a couple of things. One is, in the United
Okay.
States, we had this issue with Brown University, okay, and this murder that occurred. And the university was more interested, apparently, in protecting their reputation than they were in solving the murder. And I think the issue has to do with a lot of academic science, has to do with within the academic environment. It's all about, people basically don't want to produce theories that are going to be criticized. They want to produce theories that go along with the consensus, and that I think is because of the if you embarrass the university by coming out with some kind of harebrained theory that everybody says is wrong, that is embarrassing to the university and the organization, and I think that applies with NASA and these other government-related agencies, European Space Agency, and all these government-funded agencies. There's a lot of reviews that go on. When I worked for the government, I wrote a paper. I couldn't believe I spent more time reviewing and revising my paper than it took to write it originally. People would quibble over sentences and words and just hours in meetings. And because, the idea was, well, the government is, going to approve of this paper. This paper has the sanction of the government, and then the agency that was involved in funding the study, et cetera, et cetera. And this is a very, very it means basically people only think within the allowed lane. You have a lane that you can do science in, and you can't do science outside of that lane. And I think that's what you're complaining about. We saw that. I talked about that last week with Dr. Zaffi. When he presented his theory, his discovery was people didn't want to hear about his discovery and his theory. Okay, people want to, they want scientists to do work that makes their institution look good. Does that make sense to you, Vladimir?
You are absolutely right. No sense. It's absolutely right, 100%. And what is the most important behind of all this conservative society? Money, grants. They want to have money for their existence. They will follow this big man money as long as they will have money on it. Somebody
Right.
should stop money flow to them based on Bitcoin model and tell guys, we're ready to give you money, but please invent something new. We are tired already of all your bullshit. Simple as it. But it will not happen.
Well,
This is
there's
the
no
point.
money.
Money
There's
only.
nobody that there's no prestige person who is going to say this Vladimir Netchitailo has got this great cosmological model. That doesn't advance their statue and their careers by advancing your model. I think that's what the issue is.
Yes, you're right. You're right. And I don't know what to do about it. Harry, we talked with you.
Well,
We
my
put
point
back
is,
away.
my point is, I see this, that's an institutional problem that we can't really change.
Yes.
So, but I do, there's lots of things about this WUC model that I really like. I like particularly like the fact that, um, they haven't come to grips with the fact that the universe isn't homogeneous, and that really basically, um, you know, um, it's not homogeneous. It's a hierarchical structure. It has a structure that's not that doesn't really go along with the way they've envisioned the universe operates. This uniform. The universe looks the same in all directions. It's isotropic and it's homogeneous. No, it's not. It's not that at all. It's completely different from that. And if you're a professional cosmologist or somebody who's a scientist, it's kind of hard to come out and admit to that. Hey, our assumptions about how we're doing science are completely wrong. No, they're not going to admit to that. The most I see that they're admitting to is that maybe they made some wrong mistakes about dark energy. I see this paper that you quoted. They're saying, oh, well, maybe we were wrong about dark energy.
Harry, let me 1 minute only left. But let me tell you about your comment that it should be some bulls, short description, and so on and so on. It was your great ideas. It was a great 1 year ago, approximately. You gave me this idea, and together with you, we published the paper, 3 pages only, with only the steps of this model. And do what we have a response? No response. No, there are some people, no doubt, but well-known physicists, nobody wanted to see this. That's why today I have too many details. We missed with you, thanks to you, we missed all these details. We put these 3 pages, and what is the response? Nothing. At the end, it was even one sentence. I do remember, it belongs to you. This model waits for
Club, Vladimir.
recognition. And where is
We're
it?
not in the club. We're not associated with a university. We don't. There's the universities. It's all about advancing the reputation of the organization that you're a member of.
Yes, I know, but what is important? I'm trying all the ways, short, long, this way, that way. As I told you, more than 100,000 people